For centuries, the pyramids of ancient Egypt have stood in silent defiance of logic, time, and human explanation. Massive stone structures built with impossible precision, long before modern machinery, long before steel cranes or electric tools. Historians called it brilliance. Skeptics called it luck. Conspiracy theorists called it something else entirely. But buried beneath layers of sand, broken records, and uncomfortable truths lies a story that changes everything. Not aliens. Not magic. Something far more unsettling. What if the mystery was never unsolved, only deliberately misunderstood? This is the story of how the pyramid puzzle may have finally cracked open. The pyramids were never supposed to be questioned this deeply. From the moment modern archaeology took shape, the story of pyramid construction was packaged neatly for textbooks, museums, and guided tours. Thousands of laborers, simple tools, decades of backbreaking work. A triumph of human determination. It sounded reasonable enough until someone stopped admiring the monument and started measuring it. The Great Pyramid of Giza rose from the desert with mathematical confidence that bordered on arrogance. Its base was almost perfectly level, deviating by mere millimeters across hundreds of meters. Its sides aligned with true north more accurately than many modern buildings constructed with laser guidance. The stones fit together so tightly that even today a razor blade struggled to slip between them. This wasn't rough ancient craftsmanship. This was precision engineering. For years, uncomfortable questions were dismissed as fringe thinking. How were multi-ton limestone and granite blocks cut with such clean edges using copper tools that were softer than the stone itself? How were stones weighing as much as 70 tons transported from quarries hundreds of miles away across uneven terrain without wheels capable of bearing such loads? How were they lifted to heights equivalent to a modern 40-story building without cranes, pulleys, or iron tools? The standard explanations lean heavily on repetition rather than evidence. Ramps, sledges, manpower. Simple answers repeated until they felt true, but repetition did not make the physics work. As technology advanced, researchers gained tools the ancient Egyptians never had: satellite imaging, microscanning, chemical analysis, and structural modeling. Ironically, these modern tools began exposing how inadequate the old explanations truly were. One of the most inconvenient facts was time. The Great Pyramid alone contained roughly 2.3 million stone blocks. To complete it within the commonly accepted 20-year reign of Pharaoh Khufu, workers would have needed to quarry, transport, shape, and place one block every few minutes, day and night, without pause, without error, for 2 decades straight. Not accounting for floods, injuries, tool breakage, or political unrest. That math did not add up. Then there was the issue of granite. The king's chamber was built from red granite quarried in Aswan, nearly 500 miles away. Granite was significantly harder than limestone, and cutting it cleanly even today required diamond-tipped tools. Yet the chamber's granite beams were not only precisely cut, but fitted with tolerances that rivaled modern machine shops. Mainstream archaeology offered no convincing explanation, only reassurances that ancient people were more capable than modern audiences assumed. But capability did not replace missing methods. The deeper researchers looked, the clearer it became that the pyramids were not isolated projects. They were the culmination of a long tradition of experimentation, refinement, and lost techniques. Earlier pyramids showed structural failures, collapsed cores, miscalculations. The builders learned from their mistakes with alarming speed. This suggested an organized, centralized system of engineering knowledge, one that did not evolve slowly over centuries, but surged forward with sudden clarity. That clarity raised another uncomfortable possibility. The ancient Egyptians did not stumble into pyramid construction by accident. They followed a blueprint, not just architectural, but logistical, mathematical, and geological. The placement of the pyramids corresponded with subterranean water channels, stable bedrock layers, and even seismic considerations. These were not decorative tombs stacked wherever convenient. They were positioned with intent. Even more unsettling were the internal structures. The Great Pyramid was not solid. It contained shafts that served no funerary purpose, chambers with acoustic properties that amplified specific frequencies, and weight distribution systems designed to prevent structural collapse under immense pressure. This was not the design of a simple grave. It behaved more like a machine. Ancient texts complicated the narrative further. Hieroglyphs depicted workers, boats, rituals, and offerings, but conspicuously absent were detailed records of pyramid construction methods, no step-by-step accounts, no engineering manuals, no diagrams explaining how the greatest structures in human history were actually built. For a civilization that documented everything from bread recipes to tax disputes, the silence was deafening. Some researchers argued that the knowledge was sacred, restricted to a priest-engineer class. Others believed the methods were deliberately erased after political upheavals. But the result was the same, a historical black hole where the most important information should have been. As new discoveries emerged, resistance hardened. When alternative theories suggested water-based stone transport, vibrational cutting techniques, or advanced surveying methods using stars and shadows, critics responded with mockery rather than rebuttal. The conversation shifted from evidence to reputation management. Careers were at stake. Grants were on the line. Entire academic frameworks rested on the assumption that the old explanations were good enough. But cracks were forming. Satellite scans revealed hidden voids inside the Great Pyramid, large, unexplained cavities that challenged long-held assumptions about its internal structure. Chemical analysis suggested stone composition inconsistencies that hinted at something beyond simple quarrying. Tool marks did not always match the tools supposedly used. The pyramids were beginning to speak again. And they were saying something modern history was not prepared to hear. The idea that ancient civilizations might have possessed techniques now forgotten or deliberately ignored was no longer fringe speculation. It was becoming a serious question, not about aliens, not about magic, but about lost human knowledge. If the pyramids were built using methods we no longer understood, then modern civilization was not the pinnacle of progress it liked to imagine. It was a survivor of amnesia, and that possibility made people deeply uncomfortable. Because once the first assumption fell, everything else had to be re-examined. Ancient medicine, engineering, astronomy, even social organization, the pyramids were not just monuments, they were evidence. Evidence that someone, somewhere in the ancient world, solved problems we are still arguing about today. As the desert winds continued to strip sand from stone, the pyramids remained unmoved by modern debates. They had waited thousands of years already. They could wait a little longer. But the question was no longer whether the construction mystery could be solved. It was whether the world was ready for the answer. By the time modern science turned its full attention toward the pyramids, the traditional explanations were already standing on fragile ground. They had survived not because they were proven, but because they were familiar. Ramps, ropes, sledges, and sheer human will had become the accepted story through repetition, not verification. Chapter 2 begins at the moment when those explanations were finally tested and quietly failed. The ramp theory was the first to unravel. For decades, textbooks illustrated long, sloping ramps made of mud brick and rubble stretching from the desert floor to the rising pyramid. It looked plausible in drawings. In reality, it collapsed under its own math. To haul multi-ton stones to the height of the Great Pyramid, a straight ramp would have needed to be longer than the pyramid itself by several times, consuming more material than the monument it was meant to build. No archaeological trace of such a ramp had ever been found. No foundations, no debris fields, no erosion patterns consistent with something of that scale. Curved ramps were proposed next. Spiral ramps wrapping around the pyramid's exterior or interior. These ideas solved some space issues but introduced new problems. The angles required would have made hauling massive blocks dangerously unstable. Turning corners with 70-ton stones defied both friction limits and common sense. Internal ramps left no consistent evidence in the masonry, no access points, no scars where stones should have been removed or reinforced. The ramps existed comfortably on paper nowhere else. Then came experimental archaeology. Teams attempted to recreate pyramid construction using period-appropriate tools. Copper chisels dulled rapidly against limestone and barely scratched granite. Dolerite pounding stone shattered unevenly, producing rough surfaces inconsistent with the clean, flat faces found in the Great Pyramid. Wooden sledges worked only under ideal conditions, on wet sand, with limited weight, and even then progress was painfully slow. The experiments proved something crucial. Ancient Egyptians could move stones. They could cut stone, but not at the scale, speed, and precision required by the pyramids using those methods alone. This forced a shift in tone. Instead of claiming the pyramids were easily built, scholars began emphasizing how extraordinary the achievement was. Words like miraculous, unprecedented, and astonishing crept into academic descriptions. But awe did not fill the methodological gaps. Admiration became a substitute for explanation. The deeper problem lay beneath the stones themselves. Geological surveys revealed that many pyramid blocks were not uniform in composition even when supposedly quarried from the same source. Some stones showed internal structures inconsistent with natural sedimentary layers. Microscopic analysis detected air bubbles, unusual bonding patterns, and chemical signatures that did not neatly match known quarry samples. This led to a controversial hypothesis. Some pyramid stones might not have been quarried at all. The idea of cast stone limestone reconstituted using chemical processes was explosive. If true, it would mean ancient Egyptians possessed a form of early concrete technology thousands of years before the Romans. The theory suggested that limestone slurry could have been poured into molds directly on the pyramid, eliminating the need to lift massive blocks. The response was immediate and hostile. Critics dismissed the idea as unnecessary, claiming it overcomplicated a simple story. But the data refused to disappear. Cast stone samples replicated under laboratory conditions showed striking similarities to certain pyramid blocks. Mold lines, irregular internal grain orientation, and unexpected chemical residues matched observations on site. If even a fraction that the pyramid was cast rather than carved, the entire labor and logistics model collapsed. At the same time, researchers studying ancient water systems uncovered another neglected factor: hydraulics. Egypt was not just a desert civilization, it was a river civilization. The Nile flooded predictably, creating temporary canals, lakes, and transport networks. Recent evidence suggested water channels once extended far closer to the Giza plateau than previously believed. Some stones may have been transported by barge almost to the construction site itself. More controversially, water may have been used vertically. Hydraulic lifting systems using water-filled chambers to raise stones incrementally were proposed. Such systems required no advanced metals, only basic principles of pressure and containment. Ancient Egyptians understood water management intimately. They built canals, reservoirs, and flood controls with remarkable efficiency. Yet this idea too was sidelined. Why? Because it implied planning, coordination, and engineering sophistication that contradicted the image of ancient workers dragging stones with ropes. It suggested that the builders thought like system designers, not brute laborers. As evidence accumulated, the academic response became increasingly defensive. Instead of asking how the pyramids were built, discussions focused on why alternative theories were unnecessary. Papers were published rebutting ideas before they were fully explored. Conferences avoided controversial topics. Funding quietly favored safe research paths that reaffirmed established narratives. The mystery was no longer scientific. It was institutional. Then came the scans. Muon tomography, a technique using cosmic particles to peer inside solid structures, revealed massive voids within the Great Pyramid. Not cracks. Not structural flaws. Large, deliberate spaces whose purpose remained unknown. These voids had no place in the traditional pyramid model. If the pyramid was simply a tomb, why include vast empty chambers with no burial function? Engineers studying the scans noticed something else. The voids aligned with stress distribution zones, suggesting they played a role in managing weight and preventing collapse. The pyramid was not just stacked stone, it was internally optimized. That optimization required advanced understanding of load paths, pressure points, and long-term stability, knowledge that modern engineers recognized instantly. But acknowledging that knowledge meant rewriting history. At the same time, Egyptologists revisited ancient texts with fresh eyes. References to raising stones like feathers and commanding blocks to move had long been interpreted as poetic exaggeration. Now, they sounded suspiciously technical. Descriptions once dismissed as myth began resembling metaphorical explanations of lost technology. Even the workforce narrative began to fracture. Yes, workers' villages were found. Yes, evidence of organized labor existed. But these findings proved support systems, not construction methods. Feeding workers did not explain precision engineering. Logistics did not explain mathematics embedded in stone. The pyramids encoded constants, proportions, and alignments that went beyond funerary symbolism. Pi appeared in the structure's dimensions. Cardinal alignment reached near perfection. Astronomical correlations hinted at knowledge of precession cycles spanning thousands of years. This was not accidental. The more pieces surfaced, the clearer it became that the pyramids were not built using a single trick or secret. They were the product of a system one that integrated geology, astronomy, mathematics, chemistry, and water management into a unified process, a process now broken into fragments. By the end of this chapter of research, the question had shifted dramatically. It was no longer how did primitive people build something so advanced? It became, what did ancient people know that we no longer do? And perhaps more disturbingly, why was that knowledge allowed to vanish? The pyramids were no longer monuments of brute force. They were monuments of lost intelligence. As the old explanations crumbled, a new picture began forming, one that challenged modern arrogance and suggested that history's greatest secret wasn't hidden in stone, but in selective forgetting. And in the next chapter, that forgotten system would begin to take shape.